Hello students, in this video we will look at how hydrogen atoms bond with each other. We'll also look at how atoms of oxygen and nitrogen bond with each other. And to depict the bonding, we will use electronic dot structures. So we represent them in the form of dots or crosses, okay, and those are the electrons, and the electrons which are there in the outermost shell or the valence shell. So let's look at the first element, that is hydrogen. So hydrogen, as we know, the atomic number of hydrogen is 1. So that means there is only one atom in the outermost shell. Okay. So only this atom, those electrons which are there in the outermost shell or the valence shell can participate in the bonding or participate in the pairing up procedure. For the to know what are valence shells and what is a valency and what are valence electrons, please go to the video where we have discussed all these terms with examples. The link for that is given in the description below. So in case of hydrogen, it fills up only the K shell. So the K shell, only one electron is present in that. So if we take these two circles as say atoms, okay, these are two hydrogen atoms, let's say. So they will have just one electron each. So what, they can't lose that electron, neither can they gain electron. They can't lose that electron because it is tightly held by the nucleus of hydrogen atom. It can't gain another electron because the space over there is so small that though there is a space for another electron to come, it is just not possible or not just feasible for that electron to come in. It will actually disintegrate. So it is not possible. So the only thing possible with hydrogen atom is to share the one electron to gain stability. And how will it, to gain stability, it needs one electron only, because as we know that the space available is just for another electron. So then it will fill the K shell, and K shell, if you remember, has space available only for 2 electrons. So what it does, it shares these 2 electrons. I'll use a different color so that it will become easier for you to visualize. So instead of blue, I'll just use red over here. I'll change this also to red, so we know what is getting shared. So when they bond with each other, hydrogen atoms pair up with hydrogen atoms, it looks something like this. We have hydrogen and we have hydrogen atom over here, and then there will be sharing between the two in this fashion. So this electron comes from this atom and this electron comes from this hydrogen atom, and this is how the sharing takes place. If you look at the structural formula, the structural formula of hydrogen pairing will be looking something like this. This dash between the two symbolizes the bond between two hydrogen atoms. Okay, so this is how we show the electronic dot structure. Sometimes you put dots, sometimes you can put crosses. It's okay. Let's go to oxygen next. Now oxygen has an atomic number 8. So the distribution of electrons takes place as 2 in the K shell and 6 in the L shell. Okay, so we are only interested in the electrons in the outermost shell, that is the valence shell. So there are 6 electrons in the outermost shell. So those are the 6 electrons will show over here. So I'll put this as oxygen atom here and I'll show 6 electrons. So 1, 2, 3, 4, 5, 6, and I'll show 6 electrons here as well in this oxygen atom. Here you go. Okay, now These 6 electrons symbolize the electrons which are present in the valence shell. So these are the valence electrons only, and only the valence electrons participate in the bonding. Now, how does the bonding take place between two oxygen atoms? We'll look over here. So we'll put oxygen atom over here, and we'll put oxygen atom over here. So these are two oxygen atoms. Now these overlapping circles represent the sharing between them. So only these two get shared. Okay, these two electrons which you see over here get shared. So it is something like XX and XX. The remaining remain inside, like XX and XX over here, and over here it would be XX and XX. Okay, so only these two. Now the fact that this two crosses over here represent one bond. So this is actually one bond. I'll just depict this way. So that means there are two bonds between, and when you look at the structural formula of oxygen, it will look something like this. Bonding between two is a double bond. So this symbolizes one bond, this symbolizes the second bond between them. Okay, the reason why this bonding takes place this way is because oxygen cannot lose 6 electrons, but it is easier for oxygen atom to gain 2 electrons. So what it does is it looks to share 2 of its electrons with each other. Okay, in that way they are not losing the 6 electrons, they are there, and this atom on the red side, okay, it needs 2 more electrons to fulfill its octet of 8. Okay, to remember, to get stabilized it needs 2 more, so that it gains the stable configuration of a noble gas, that is 2, 8. So what it does is it takes 2 electrons from, or it basically pairs up with 2 electrons from this atom, and same thing is done by this atom. It pairs up with 2 electrons from this oxygen atom. As a result, they satisfy each other in having 8 electrons by sharing between each other, and that's why we get a double bond, because there is bond formation between 2 pairs of electrons. Got it? And lastly, we look at bonding in nitrogen atoms. So for nitrogen has an atomic number, that is 7. Okay, so the distribution of electrons would be 2 in the K shell and 5 in the L shell, which means that it needs 3 more electrons, okay, to satisfy the condition of getting a full octet or noble gas configuration. So if you put it down over here as nitrogen, and over here is nitrogen atom as well, we are looking only at the 5 electrons which are present in the outermost shell, the valence electrons. So they will be distributed something like this. Okay, we have 2 over here, 2 over here, and 1 over here. Okay, and we have over here XX, then we have XX. Okay, so these are 5 electrons present in the outermost shell of the nitrogen atoms. Now, how does their distribution take place? So we'll put it down over here. Okay, now in case of distribution, what happens is they need 3 electrons each, which means that you need to put 3 electrons over here from either side. So if we take out 3 electrons for sharing, what remains inside are just 2 more electrons. So we leave them over here, these 2, the ones on the top, and that is what we get. Now if these 3 pair up, that means we have got now 3 bonds. We have 1, 2 and 3, and structurally it will look like this. Okay, triple bond. between nitrogen atoms. The reason why 3 electrons are being shared is because they need 3 electrons for stable noble gas configuration of 2,8. Okay, so what it does is it looks to share between each other 3 electrons. So 3 electrons it gets from the other nitrogen atom, and the other nitrogen atom gains 3 electrons from this nitrogen atom. A mutual understanding between the two, and we have a good nitrogen bonding between them. It's triple bond formation over here, as we see in case of nitrogen. So in this video we have gone through the bonding, how hydrogen atoms, oxygen atoms and nitrogen atoms bond with each other based on the valence electron, that is the electrons present in the outermost shell, and as we see they share it with each other without stealing it from each other. There is a mutual understanding between the two atoms of these elements, and they pair up. Now in case of hydrogen, we saw it forms a single bond between two hydrogen atoms. In case of oxygen, they form 2 bonds. So there is a double bond formation between oxygen atom, and in case of nitrogen, as we see over here, there are 3 bonds formed, and the type of bonds, whether they are single bond or double bond, the number of bonds is in, okay, or whether it is a triple bond, is influenced by the number of electrons needed in the by the particular atom that is in the outermost shell to gain noble gas configuration. Fine. So if you have liked this video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and click on the bell icon to be notified whenever a new video is posted. Thanks for watching. See you in the next video.